Good morning, grade 6. How are you today, Miss? Today, Miss, inshallah, we will continue the second part from equivalent ratio lesson. And actually, we will speak about proportion. We will need a proportion more in the lesson that comes after this. We will need it when we want to find out, unknown values from the real life problems. Now, but it's good now to mention it since they use it actually to they depend on proportion if we want to make a comparison between ratios and see if they are equivalent or not. Now, actually, what is proportion? What are proportions? Now, a proportion is you remember when we said that I have equivalent ratios are actually two ratios that they are equivalent and they have the equal sign between them. Okay, actually this is a proportion, and since the proportion is an equations with two equal ratios, so why do I need a proportion? And most of the times now when you have two ratios that are equivalent, one of the quantities, okay, it means one of the numbers in these four numbers, as you can notice here, will be a known number like x. So I will use a proportion to find it out. Okay, now I will use a proportion more to find out a quantity or a number that's unknown, a value that's unknown in the other lesson. But today, actually, they will depend on it in finding out if two ratios are equivalent or not. Let's remember together on what we depend to find out if two ratios are equivalent or not. Last time, actually, we depend on the unit rate. We say that we can find out the unit rate for the two ratios. Every one ratio yani alone, we can find out the unit rate for them. Now, if the unit rate is equal, actually, so we can decide or we can conclude that our ratios are equivalent. Why? Because in unit rates the denominator is 1. So if the denominator is 1, so the two values in the numerator they should equal the same. To say that we have a unit rate that is equal in both, ratios, right? Now, if a unit rate is not easily found, use equivalent fraction to decide whether the ratios or rates are equivalent. Now, if I cannot do it with the unit rate, how is that? When, when you divide numerator by the denominator, you cannot get a whole number, a unit, okay? A whole unit. You will find out as a decimal or as a fraction. Now, I cannot decide if they both are equivalent ratios or not. So what shall I do? I will go to the equivalent fractions, which is proportion. Okay, equivalent ratios show me proportions. Now, as you can see here, equations, yes, we said that, okay, 2/3 equals 4/6. Now, to find out, okay, if this, this is one kind of proportion. It tells me that this ratio here is equivalent to this ratio here. I will not find out if it's equivalent or not. It is equivalent, Miss. Why? Because actually there is the equal sign between them. So they should be equivalent, okay? And if you can notice, there is a common factor between 4 and 6, which is 2. If you divide it by 4, it will be 2. If you divide it by 6, it will be 3. So we refers back to 2/3, which is the other ratio. And even though here 5/15, if you try to simplify it, you will notice that it will be 1/3. So we are in the same, in the same cycle, okay? In the same cycle. Now, why do we need proportion? Actually, we can use a proportion to find out variables or unknown variables. Okay, that the variable, it depends on the idea that my ratios are equivalent. So the proportion tells me that how can I find out a missing number if I have equivalent ratios, okay? Now, As you can see here, what's the proportion are when you look to these two equivalent to these two fractions, I can find out that they are equivalent. How? Because actually in the easy way I make cross multiplication between them. Okay, so I multiply 2 times 25, as you can notice here, 2 times 25 and 10 times 50. And the answer here will be 2 times 25, it's 50, and 5 times 25, 5 times 10, it's 50. So now the easiest way to find out that these two ratios are equivalent or not, actually by make cross multiplication. By multiplying the the denominator by the numerator and the other numerator by the other denominator, cross multiplication. This is an easy way to find out if these two ratios are equivalent or not. So till now I have learned two methods to find out if my if my ratios are equivalent or not. One of them is find out the unit rate. The other one is find out, or depends on the idea of proportion. How can I find out equivalent, if ratios are equivalent or what? By the unit rate, by dividing the numerator by denominator to get a denominator of 1. I want the denominator to be 1, so I have to divide the numerator by it. Okay, how can I find out, or how can I depend on proportion to find out if my ratios are equivalent or not? By make cross multiplication. I multiply one of the numerator with the other denominator ratio, and then multiply one of the ratios numerator, the other ratio numerator with the first ratio denominator. Okay. And as I have said, I can depend on it to find out. I can depend on the proportion to find out the the missing number, which I will need it more in the other example. Okay, miss. Now here I just want you, if you can notice here, this is a proportion picture, as they say. The ratio compares one thing to another. A proportion is two ratios set equal to each other. Checking for proportions can be mystifying, okay? But you can make them simple by just cross multiplying, okay? Now how? Look, if you just look and ignore the poem, which is nice, but if you look here, I want to find out if these ratios are equal or not. So as they say, the simplest way is by making a cross multiplication and find them out. If you can see here, I use the proportion to find out missing number to the missing quantity or missing numerator here, and I make cross multiplication, for example, here to find out another missing or unknown value. And I ask myself here, how do I, and this is one kind we solve it in finding values of the ratio tables, that how 2 becomes 12, I multiply it by 6. So I ask myself, what do you think, what do I have to multiply 2.5 with? I multiply it by 6 again. Why? Because these ratios are equivalent, so whatever you do here, you should do it here. Okay, miss. So actually, let's say that we will go back to these slides in explaining proportion and finding out missing values from ratios in the other lesson. But today we will go back. Now we will go back to the lesson. We will go to the exercises in lesson and find out if two ratios are equivalent or not, depending on unit rate and depending on proportion. Yalla, miss. Let's go there.